attended the test? I think no one attended from your batch.
Hi Prashanti, I have attended.
I attended, ma'am. I also attended, ma'am.
Okay. How much you scored?
I didn't get any score.
I have attended. I got a score of 20, but I feel like the assignments which were like about to do on paper, they were not graded, so it's not a complete grade.
Complete grade, huh?
Like
Okay.
there were some questions which were supposed to answer on the paper and upload it. I guess those questions were ungraded. I don't know. Just I'm feeling like that.
15 you scored. Sorry. $44. Okay. Where you didn't got the answers? For some questions, there is no explanation, right? Only output is there. Correct or wrong answer.
Yeah, there were some MCQs and some were like written type questions.
Okay. So do you need to know any answers for any questions?
Uh, no, I guess.
Okay. Yeah, if you want to know any answer for any questions, ping me in the WhatsApp group. I will share you the answers. Okay.
Okay.
Yeah. What about remaining Ravina and Pranay? I seen your names before. What about remaining?
Prashanti, I'm a new joiner, so can you share me the link for the test so that I'll take after the class?
Yeah, sure. I will share. I will share for digital electronics and Verilog. Okay. So, Ramya, have you attended?
Yeah, actually, I forgotten when I will attend today.
Okay. What about Navin Manimala?
The assessment you are asking, right?
Yes.
I have already taken. Yeah.
Okay.
Yeah, so I'm a new journey. You have to go through those. Not a tough.
Okay. So, yeah. So we'll follow some order. I will ask one by one question. So you can answer. Today we'll discuss in a group. Okay. And I will share you some questions. Based on that, I will take one-on-one mock interview in the coming days. Okay. Today, just I want to test from everyone. So here, if you see first, Pravina, note down your numbers. Accordingly, you need to answer. First Pravina, then Manimala, then Navin, third Navin, fourth Nitya, fifth Pranay, sixth Ramya, seventh Vishal. Okay. So I'm going to ask from scratch to advanced level questions. Today only theory type questions, not practical. You already worked on practical questions, right? Some logical questions. So we'll revise some theory questions today. Okay. So first question.
One
What is
second.
the
Hi, Prashanti. So I said you, I have recently joined. I've just started my classes from yesterday, so I don't think I'll be able to answer as of today.
Okay, then you just skip. Okay, in place
Yeah,
of Malima, who are next? First Pravina, second Navin, then Nitya. Do you want to join?
Yes, I want to join. Yeah.
You can try. You can try
Yeah,
at least.
yeah.
Okay.
I'll try. Yeah, yeah. I'll do that.
Yeah. Okay. First Pravina, then Navin, then Nitya. Fourth Pranay. Next Ramya, Vishal. Okay. So first question. What is the difference between flip-flop and a latch? One practical application for latch and the practical application for flip-flop.
That is difference between the latch and flip-flop. Latch is level triggering. When flip-flop is an edge triggering. Latch is an uncontrollable. Flip-flop is an controllable. Flip-flop is used to store the data. Coming to the practical applications, flip-flop is used for storing the data, one bit of data.
That's it.
Yes, ma'am.
Are you joined from laptop or mobile phone, everyone?
Laptop only.
So you can work on some problems also, right? If I ask, you can share and you can do. Is that okay, everyone?
Yes, ma'am.
Okay. Okay, next question. What is the difference between combinational logic circuit and sequential logic circuit?
Yeah, Praveen. Combinational logic circuits are means that the output totally depends on the present input, and it does not depends on the history of the other older output. But in say sequential circuit, it may depend on the older output also.
Okay, that's it. Huh?
Yeah, I have not looked into the sequential circuit yet. I have completed only combination circuit.
Okay, so just you can try basic difference.
Uh, in combinational circuit, we do not have any clock related stuff, but in sequential circuit, we have a clock
Mhm.
part. And in combinational circuits are means mm, that's it. Yeah.
Okay, okay. So next one. What is the difference between multiplexer and a demultiplexer and practical application of multiplexer and demultiplexer?
Yeah, multiplexer has like four. I mean, suppose like we have 4x1 multiplexer, it means four inputs and one output. It has two selection lines, so 2 power n inputs and selection lines and one output. And demultiplexer is vice versa of that. So it has like one input and two selection lines, and I mean n selection lines and 2 power n outputs.
Okay, what are applications?
Basically, multiplexer is used for selecting any appropriate random addresses, like when we are applying.
Mhm. You are not audible.
Yeah, can you audible?
Applications, yeah, mux and demux.
Yeah, uh, to select the basically, if we have like applications, uh, suppose we have like case statements like like 3 or 4 case statements, then we'll be using multiplexer to implement that.
Okay. So basically, case or if else is a parallel mux and serial mux. Okay, that is depend on Verilog. In digital electronics, where we use the multiplexer application wise.
No idea.
Okay, so mostly mux and demux we use in a communication purpose. As you said, mux is many to one based on the selection line. So we can select, suppose one device, there is a computer. Okay, so computer can be connected to many devices externally, like a printer or scanner, different devices we can connect. So how we can access the computer to particular printer? You want to send the data for printer, then we need to select a printer. If you want to send the data for some audio, there is audio speakers. So if you want to listen something from speakers, you need to select. Like that, multiplexer and demultiplexer is used, one to many, many to one. Okay. And next question. What is the difference between encoder, decoder, and what are the applications? Pranay?
Yeah, hi Prashanti. So encoder means is similar to, I mean, in practical applications. So what are the messages there? So we use it to encrypt the data and transmitting via signals. So in that time, we are using the encoder. And the decoder we use in the receiver part. So where the signal comes to the receiver end and it will decrypt the code and it converts to the original message. So basically, it is used in the practical applications in communication systems. And uh, so it's similar to like a multiplexer, so the encoder.
Okay. Okay. That's it.
Uh, and yeah, mostly that's all. I mean, for the decoder means we're used to have the n inputs and the output has a 2 power n outputs, similar to demux.
Okay. Can you convert a demultiplexer into decoder?
Mm,
You can share your screen. Suppose demultiplexer have, if you take 2x1 demultiplexer, there is a one input, two outputs, and one selection line. For decoder, same 1x2 decoder, one input and two outputs, right? And one enable signal will be there for decoder. So how
yeah.
both will work similarly?
In the demultiplexer, based on the selection line only, so the input will goes to the output. But here in the decoder, so based on the combination, so I mean, for a two to four decoder, maybe if the selection, if the input is 0 0, so the first output, I mean, the F0 will activate and the rest all will be the 0. I mean, the combination will be like 2 to 4, right? For 0 0, so the output will come as 1 0 0. So likewise, it will be there.
Okay. Next, Ramya. What is the difference between register and a counter and practical examples?
Yeah,
And which
register
flip-flop
is
is
nothing
used in register and which flip-flop is used in counter? Yeah, go on.
the register is used to store the data, whereas a counter it is used to count the number of states, number of states and number of pulses. Counter for the counter purpose, we use the toggle flip-flop and JK flip-flop. For the data storage, we use it D flip-flop.
Okay. What is the difference between synchronous counter and asynchronous counter?
Yeah, synchronous counter is depends on clock. Async that means output of the first flip-flop is given to the is given to the second flip-flop as a input. It is asynchronous counter. Whereas counter, same clock is given for all the flip-flops. That is synchronous counter.
Okay. That's it. Huh?
Yes.
Okay. Next, Vishal. What is the difference between Mealy mission and Moore mission and practical examples of finite state mission?
A Mealy machine is the machine in which output depends on current state and the current input, whereas in Moore machine, output depends only on the current state. Coming to practical applications,
Differences only, that's it. Huh?
I can recall only now.
Any other differences? Which one is mostly preferred? Practical, either Mealy or Moore?
Mealy?
No.
No.
Why Mealy? Why
Because
Mealy?
oh, sorry, I cannot recall it.
Okay. Travina, can you answer what is the difference between Mealy and Moore and practical applications of FSM?
Yes, ma'am. Coming to the Mealy, the output is depend upon the present input as well as a previous output. Coming to the Moore, it is only depending upon the present input only. And also, Mealy has an n state and the Moore has an n+1 state. But more practically, we're using a Moore mission. Why? Because it is only depending upon the present input only. It is taking only single input. So that's why we are considering the more practical applications, because it will avoiding the more glitches. I think glitches is avoiding in the more emission. The practical examples are traffic light signal or ATM missions are coming to the FSM example.
Any digital applications we use FSM, and what is the limitation of Mealy?
Mealy will, because of Mealy, we are using two different inputs are taking, right, ma'am? It is depending upon the present input as well as previous. Due to this, there is a delay in the one output. One is coming fastly, maybe another one is coming some delay. There may be chances to produce a glitch.
Okay. Okay. So next question, MR. Who is MR? What is your name?
Oh, okay. Sorry, my full name isn't here. Madhu.
Yeah, Madhu. Okay. So what is the difference between glitch and hazard, and what are the techniques to avoid the glitches and hazards?
Okay. So glitches mostly occur because of delay. So when we have 3 or 4 inputs, and then if there is any delay, propagation delay that is happening, then we might have glitches happening. And hazard is transitioning between. So hazards usually happen because of the transition from 0 to 1 or 1 to 0. And I think we have two types of hazards. That is, one is static hazard and the other is dynamic hazard. And how do we avoid is like by adding some redundancy to the circuit. So for example, when we draw a K map, we would have taken only those common spots, right? So if we include those redundant expressions also, then probably that can help in avoiding the glitches or hazards in the circuit.
Okay. Any other techniques?
Any other techniques?
We can also use flip-flops at the
Yeah,
end.
yes, we can do that also. Yes.
We can add delays, buffer gates.
Yes.
Okay, next Naveen. What is the difference between setup time and hold time in flip-flop?
I have not looked into the flip-flop part yet, sequential circuit.
Okay. Then suppose sequential circuit it did look right. Okay. Can you share your screen? Can you implement a XOR gate? Can you implement a 4x1 multiplexer as a XOR gate?
4x1
Multiplexer as a XOR gate. XOR gate functionality using 4x1 multiplexer.
XOR gate. Okay.
You need to draw. Yeah. Meanwhile, you can share your screen and draw. Next, Nitya.
Okay.
What is the difference between FIFO memory, which is a sequential, and a non-sequential memory like a RAM ROM?
Yeah, FIFO is basically used to store the data streams, like multiple data streams. It has like read pointer, write pointer, and the read pointer. So FIFO depth is depends on both read pointer and the write pointer frequency. And we have like static RAM and dynamic random access memory like DRAM. So these are static RAM, SRAM, and DRAM is basically DRAM is used to access the uh, like memory mapping, like dual port memory mapping purpose. And static RAM is to access the random access of data transfer.
Okay. That's it.
Yeah, and the FIFO is used to overcome the metastability condition. Whenever signal cross from one frequency domain to the other frequency domain, so we'll use asynchronous FIFO to overcome that.
Can you explain the metastability behavior, unpredictable behavior in digital circuits?
Yeah, when a signal, for suppose we have like flip-flop, when two signals are arriving at the same time to the flip-flop, this might leads to metastability. It has to be setup condition and hold conditions to arrive at the signal to the flip-flop. So this might lead to metastability. This is the one condition. And the second condition we might occur when signal cross from one frequency domain to the other frequency domain module. So it may not receive it proper at the second end of flip-flop, second domain. So this leads to metastability. So to overcome this, we can add at end we can add extra flip-flop so that we can easily catch up the signal without any glitch.
Okay. Next question, Shanay. Design a digital circuit which detects the odd number of ones in a stream of bits. Design a digital circuit that detects odd number of ones in a stream of bits. Either you can design using the gate or FSM or any register or counter, your wish. It should detect an odd number of ones in a stream of bits.
So I think we can use the XOR gate to detect the odd number of inputs.
Okay.
Yeah.
Okay. Next question. Next, Ramya, right? Can you design a 4-bit binary comparator using the logic gates?
Using logic gates.
Yes, 4-bit comparator using logic gate. And Navin, you need to get your answer.
Yeah, I will click a photo and send it. I'm using phone, so
Okay, you can write in a book and you can send. What about Ramya?
Yes, ma'am, I believe.
A 4-bit comparator using logic gates. Next, Vishal. Can you implement a 4-bit synchronous counter using JK flip-flop? 4-bit synchronous counter using JK flip-flop. Everyone, you can share your screen or you can draw in your notes and share me. Next, Pravina. Suppose you have a circuit with the 4 D flip-flops which are connected in series. Okay. Initially, all outputs are 0. Initially, all outputs are 0. A pulse is given to the input. What will be the output of each flip-flop after 3 clock cycles? Did you noted the question?
Yes, ma'am.
You have a circuit with 4 D flip-flops connected in series. Initially, all outputs are 0. A pulse is given to the input. And what will be the output of each flip-flop after 3 clock cycles? You can draw and send to me. Next, Madhu, your question. How do you detect a sequence 1101 in stream of bits? By using the finite state mission, you need to draw 1101, Mealy and Moore.
So, do I need to draw the state transition diagram?
Yeah.
Okay.
You can draw and send me, or else you can share your screen and draw. Next,
Okay, I'll
after
draw.
Madhu, yeah, 1101. Okay. Next, Navin, your second question.
okay.
You need only combinational logic circuit, right? Okay. Can you draw 16 by 1 multiplexer using 4 by 1 multiplexer?
16 by 1 multiplexer using 4 by 1, right?
Multiplexer, yes.
Okay.
Next, Nitya.
One
How
quick
do you
question,
design?
Prashanti.
Yeah.
Do I have to consider overlapping as well as non-overlapping, or is it just one case?
Non-overlapping enough.
Okay.
Okay. Next, Nitya. How would you design a circuit that counts the number of ones in a binary number?
We can use odd parity.
Okay.
So using odd parity, we can say number of ones.
Okay.
Or odd or even, yeah.
Particularly any gate?
I will use XOR gate.
Okay. Next question. Take next question. You only. Design a logic circuit that detects if a 3-bit number is a prime number.
Okay.
Design a logic circuit that detects if a 3-bit number is a prime number. 2, 3, 5, 7, between 0 to 7, 3-bit means. Okay.
Yeah. So you
So
want
how?
me to write code in Verilog now?
Not in Verilog. Design the circuit diagram.
Okay, circuit diagram. Okay.
Yeah, you can create by using gates. You can use combinational logic circuit or sequential logic circuit or FSM, however. And
Yeah,
next question, Pranay. How would you design a binary counter that counts from 1 to 10 and then reset? Binary counter that counts from 1 to 10.
Okay.
Next question, Ramya. How can you implement a full adder using only 2 multiplexers?
Full adder using 2 multiplexer.
Yes. How can you implement a full adder using 2 multiplexers? What?
2:1 multiplexer or 4:2?
Whatever the multiplexer, you need to use 2 multiplexers only. Okay.
Actually, I drawn for a single bit comparator.
Okay, then take another question. Already you did for comparator, right?
A single
You
bit
tried.
comparator I tried, ma'am.
Okay, then take another question. Design a 3-bit gray code counter.
3-bit gray code.
Gray code counter. Okay. Next, Vishal. How can you implement a full adder using only 2 multiplexers?
Okay. Two
Next.
The multiplexes are
Only
like
2 multiplexers. Yeah. Full adder using 2 multiplexers. Next, Pravina. How can you design a glitch-free 2x1 multiplexer? How can you design a glitch-free 2x1 multiplexer? You can answer or you can take time and you can write and share me, okay?
Okay, ma'am.
Next, Madhu. Suppose a 4-bit binary number is given, okay? Design a circuit that output 1 if the binary number is a palindrome. 4-bit number is given, output must be 1 if the input, if the binary number is a palindrome number. Okay.
Just a quick question. So, for example, can you give me an example of a binary number that looks like a palindrome? For example, 0101. Is that what you mean?
Yeah, in a 4-bit means total 16 combinations will be there, right? In that 16 combinations, you need to take the palindrome number. Okay, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These all are palindrome numbers in 4-bit.
Okay. Okay.
Okay.
So even 111 will be a palindrome number, right? 1001.
1001 is not a palindrome. 0, 1, 0 from 0 to 9 all are palindrome only. 0, 1, 2, 3, like that. If you take from 11, after 11, 11, 22, 33, 44, 55, those all are palindrome.
Okay.
Okay. Next question. Who is that? Navin. Combinational logic circuit. Suppose design a digital logic circuits that detects whether 4-bit binary number is multiple of 2 or 4. That detects whether 4-bit binary number is multiple of 2 or 4. Next one, Nitya. Design a frequency divider circuit that divides the input clock frequency by 5. So how would you implement it? Design a frequency divider circuit that divides the input clock frequency by 5. So how can you implement that? Okay.
Okay. Yeah.
Next, Pranay. Explain how would you or you can implement a ALU, arithmetic logic unit, capable of performing addition, subtraction, and or XOR operations. You need to draw the truth table for all operations and a circuit diagram. Okay, so try to implement some logically, okay, in optimized way.
So how many inputs shall I take? Maybe it's up to myself, or
you can take 2 or 3 inputs. Anyway, gates is a multiple input, single output, right? You can take any number of inputs. 3-bit you
okay.
can construct simply. Okay.
So can you
Next,
tell me once again? Addition,
addition, subtraction, and or XOR operations.
Okay.
Next, Ramya. How would you design a 3-bit binary to 7-segment display decoder?
3-bit binary to
7-segment display decoder. Okay. Next, Vishal. Can you design a parity generator and checker for a 4-bit binary number? Design a parity generator and checker for a 4-bit binary number. And also take another question. How would you design a binary multiplier using a sequential circuit? 2 questions. Okay. How would you design
Binary
how
multiplier?
binary multiplier using a sequential circuit?
Okay.
Okay. Next, Ravina. How would you design a circuit that ensures no race conditions in a sequential system? That is first question.
Okay.
How would you design a circuit that ensures no race condition in a sequential circuit? Second question. How would you design a digital filter to remove noise from an input signal? How would you design a digital filter to remove noise from an input signal? Next, who is next? Madhu. Suppose you have a circuit that exhibits intermittent glitches. Okay. So how
Okay.
would you debug that? And next
So is it
question.
beside any circuit or is it like just logical question?
It's a logical question. You can write regarding race condition setup hold violations.
Okay.
Okay. Next question. How would you, before I think I given finite state machine, right, for you? Madhu.
Yes. Prashanti,
Okay.
can you repeat the question?
I have given, have you written first question?
The Moore and Mealy, right? I have sent it to you. Yes.
No, glitches question.
Yeah,
Okay,
I've noted. So, yes.
Second question. Implement a digital circuit to multiply a 4-bit number by 7 without using a multiplier.
Multiply a 4-bit number by 7.
Design a circuit to multiply a 4-bit number by 7 without using a multiplier.
Okay, so do we use shift operators here?
You can use shift and addition operations.
Okay.
Next question. Next to Naveen, right? From combinational logic circuit, how would you design a priority encoder with 8 inputs and 3 outputs? That is very easy.
Can you repeat again? I missed it.
Wait, let me give him another question. Draw the digital circuit for LCD display.
Draw
Digital circuit for LCD display.
digital circuit.
Next, Nitya. Design a 4-bit cyclic redundancy check CRC generator for error detection.
Can you repeat the question?
Design a 4-bit cyclic redundancy check CRC VTEL. CRC generator, cyclic redundancy check generator for error detection.
Okay.
Naveen, you also can design this one. It's for combinational only. You also write. Design a 4-bit cyclic redundancy check generator for error detection.
Designer.
Cyclic redundancy check CRC generator for error detection.
Redundancy check for.
Next, Nitya, your next question. Suppose your any task is given with optimizing a design for area and power. Okay, what are the techniques you use like to optimize a design in terms of area and power?
Area and power. So if
you can write, you can think later and write.
Okay.
Next, Pranay, your question. Design a circuit that generates 25% duty cycle square waveform.
Okay.
And 50% duty cycle input clock. That's one. Design a circuit that generates a 25% duty cycle square waveform from a 50% duty cycle input clock.
Okay.
Next question for you. How would you design a state machine that debounces a mechanical switch?
It's me only.
Yes.
Can you repeat again? Sorry.
How would you design a state machine that debounces a mechanical switch?
Okay.
Okay. Remaining also, you can note all the questions and you can try. No problem. And next question for Ramya. Explain how would you pipeline a combinational circuit to improve its clock frequency? Explain how you would pipeline a combinational circuit to improve its clock frequency. Completed?
Explain how pipelining a combinational circuit to improve input frequency. Na?
To improve its clock frequency.
Ma'am, actually, as not about ma'am, you have given a question for 3-bit binary code, 3-bit gray code counter, ma'am. Actually, I drawn a state diagram. After that, what I have to do?
3-bit counter, gray counter I told, right?
Yes, ma'am.
Gray counter. See, for synchronous counter, 3-bit counter, how you will do? First we'll take 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, like that states. But gray code counter means for 0, what is the gray code? For 1, what is the gray code? For 2, what is the gray code? Like that you need to take what is the first value, what is the next value. Like that till 3-bit, till 7, you can take the gray code. Based on that, you can write what is the present state and what is the next, present value and next value. Okay.
Okay, we have to write truth table, ma'am.
Yes.
Yeah, okay. Actually, I drawn a state diagram for that.
Same as a synchronous counter.
Got it.
Or else I will show. Wait 1 second. Suppose if you take a normal synchronous counter, what we will do? Present state is 0, next state is 1, next state is 2, 3, 4, 5, 6, 7, again 0. So when you are writing a truth table for counter, what we will write? What is the present state and what is the next state? Based on that, we will create the expressions and we'll write the counter logic in terms of flip-flop. That is what synchronous counter. Okay. Same for gray code counter. You need to write the gray code for 0. Gray code for 0 is a 0 only. Gray code for 1, 1 only. Gray code for 2, 3. So after 1, you will get 3. Gray code for 3, 2. So after 3, you will get 2. Gray code for 4. So check what is the gray code for 4. Then what is the gray code for 5. Then what is the gray code for 6. Then 7. Again 0. Like that, for this you need to draw the truth table. From truth table, expressions. From expression, circuit diagram.
Yeah, okay, ma'am.
Next. I didn't given now present question. Okay, note down the question first. Design a circuit to detect if a 16-bit binary number is divisible by 8 without using a divider.
Ma'am, for me.
Yes.
Yeah, you give me map about pipelining a combination, sir.
First mute your mic. I will give. So write down first question. How would you pipeline a combinational circuit to improve its clock frequency? That is a first question for you. Second question. Second question. Design a circuit to detect if a 16-bit binary number is divisible by 8 without using a divider. Okay.
Ma'am, once repeat, ma'am.
Design a circuit to detect if a 16-bit binary number is divisible by 8 without using a divider.
Yeah, okay, ma'am.
Okay. Next, Vishal.
Yes, ma'am.
Design a synchronous 3-bit counter using D flip-flops.
Synchronous thing. But
Synchronous 3-bit down counter using D flip-flops.
okay.
Okay. Next one. Design a circuit that generate 1 millisecond pulse from a 100 megahertz clock.
That generates 1 millisecond.
Pulse from a 100 megahertz clock. You can use the counter.
Okay.
Okay. So I think everyone got questions. Ravina, you can note down another question. Detect a Moore FSM. Design a Moore FSM that detect sequence 10101 by using Mealy mission and Moore mission.
One zero zero one, ma'am.
10101. Yes. 101.
Okay, 10101.
One using Mealy and Moore. Anyone?
Okay.
Did anyone need one more question? I think everyone got 2 to 3 questions. Madhu, can you note down another question?
Sure.
Design a shift register with a load, shift left, shift right capabilities. Design a synchronous shift register with a load, shift left, shift right. Universal shift register, simply.
Okay.
Okay. Yeah. So that's it. You can work on those questions and submit. Okay.
And Prashanti, if possible, can you share all, I mean, what you have asked the questions? Can you share all the
Okay.
questions?
Anyone written all the questions?
No.
Okay. Okay, I will share tomorrow.
Okay.
So
Yeah.
that's it.
Yeah,
If you
thank
have any doubts, you can ping in the group. Okay. Then thank you all. Bye.
Thank you.
Thank you, ma'am.